One gemstone was banned from trade for over 70 years, yet a private collector just paid $40,000 for a single piece, sealed inside a lead vault. Why? Because in the world of forbidden stones, beauty kills. And the one ranked number one is still alive, quietly radiating in the dark. Hi everyone, I'm Sarah, your host from World of Gem, and I'm so glad to see you again on this special journey, where we uncover the things no one ever told you about gemstones. If this is your first time here, make sure to like, subscribe, and turn on the bell, because what you're about to see will change the way you think about beauty forever. These are not jewels to wear. They are time bombs of the earth. Some once crowned pharaohs and emperors, some painted temples, poisoned artists, or blinded miners, and one, the most expensive of all, still emits radiation after 4 billion years. Why were these stones worshipped, then banned? Why are collectors still risking everything to own them? And why are some of them still sold today, hidden in plain sight? Don't skip this video, not if you ever plan to collect or invest in gemstones, because among these 30 forbidden stones, a few might be sitting quietly in someone's showcase, beautiful, priceless, and toxic enough to end a life. So take a deep breath, because what you're about to see isn't just about minerals, it's about the price of touching light. Welcome to World of Gem, where beauty and danger share the same face. Stone number 30. Arsenopyrite. The silver-gray fire of poison. Deep beneath the central European mountains, where the earth still breathes through cracks of steam and metal, lies a mineral that gleams like polished steel. Arsenopyrite, found in the ore belts of Bohemia, Saxony, and the Ural Mountains, this silvery-gray crystal was once mistaken for treasure. To the untrained eye, it shines like pure silver, but to the geologist, it's a warning. Beauty here is forged from poison. When miners first struck veins of arsenopyrite in the 19th century, they believed they had uncovered a source of iron and silver. They were half right and half doomed. The crystal's elegant metallic luster hides arsenic sulfide, FeASS, within its heart. When struck or heated, it releases the faint scent of garlic, the deadly signature of arsenic escaping as vapor. Old mining records from Saxony describe a gas that silenced birds underground. That gas was arsenic trioxide. Extraction today happens only in controlled mines, where ventilation fans roar day and night, and every worker wears a respirator. Even with modern safety, 1 gram of airborne arsenic dust can poison the air of an entire tunnel. That's why collectors call it the stone that whispers death. It's rarely cut by lapidarists, not because it's soft, but because one careless grind could send invisible toxin into the lungs. Visually, arsenopyrite is mesmerizing, a crystalline lattice of triangular prisms, sharp edges flashing between silver, gunmetal, and faint gold. Under certain light, a rainbow sheen flickers across its surface. Oxidation, revealing thin films of iron arsenide museum curators, often seal it under glass, both to preserve the shine and to protect the air. In dark galleries, a spotlight on an arsenopyrite cluster looks like frozen lightning, captured mid-explosion, yet despite its danger, the market still whispers. Some jewelers, chasing rarity, encapsulate tiny polished fragments inside clear quartz domes, turning toxicity into art. Such pieces sell for $300 to $800, depending on clarity and containment, though experts refuse to wear them. The irony is haunting, a gemstone of deadly breath worn close to the pulse. For those who handle it, the rule is sacred: never grind, never wash, never heat, only observe. Because arsenopyrite teaches one lesson older than gold, that the Earth's most dazzling treasures often come with a price measured not in money, but in caution. So the next time you see that cold silver flash in a mineral fair, remember, it might not be silver. It might be the quiet shimmer of arsenic asleep, waiting for heat, for touch, for air, to wake. Stone number 29, torbernite. The green glow of silence. High in the mist-covered mountains of Cornwall, England, miners once followed a strange green shimmer in the dark. It wasn't emerald, and it wasn't malachite. It was something colder, Torbornite, a crystalline relic born from the slow decay of uranium itself. Even before scientists named it, locals feared it. They called it the witch's emerald, beautiful, luminous, and cursed. The miners who handled it without gloves complained of dizziness, burns that wouldn't heal, and a metallic taste that lingered for days. Centuries later, science confirmed what folklore already knew. Torbornite glows not because of magic, but because it hums with radiation. This mineral forms deep in uranium-rich granitic rocks, often alongside autumnite and uraninite. Its chemistry, copper uranyl phosphate dihydrate, reads like a spell written in numbers, binding copper, phosphorus, and uranium in fragile symmetry. Every crystal is a map of time. The shimmering green plates you see under the microscope are actually microscopic vaults of decaying atoms, releasing energy that has been trapped for billions of years. In the 1800s, when industrial mining swept through Europe and Africa, Torbornite was discarded as waste. Then came the atomic age, and suddenly, every speck of green dust was gold mines in Shaba Province, Congo, Irango, Namibia, and Cornwall were reopened, not for beauty, but for fuel. Uranium companies stripped the veins bare, hauling tons of Torbornite ore to extraction plants that would later feed the world's first nuclear reactors. Collectors today treat it as both treasure and taboo. Under a glass dome, Torbornite looks like a piece of living jade, square, leafy crystals stacked in perfect geometry, each one glinting between apple green and ghostly lime, but it's fragile. Leave it under sunlight or near heat and it begins to crumble, releasing radon gas. Invisible, odorless, deadly. That's why true mineral curators seal it airtight, away from children, pets, or open air. Its value is paradoxical. $200 to $1,200 per specimen, depending on color, hydration, and origin. Yet its trade is shadowed by legal restrictions. Some countries ban shipping it entirely. Others require radiation certificates. The risk isn't in touching it once, it's in keeping it near, letting it breathe in your home. Still, for a few, that risk is the allure. They see Torbornite not as poison, but as proof that Earth's most dangerous forces can crystallize into art. It's the stone of containment, a reminder that beauty and decay are twins, bound by time. Stand before a Torbornite cluster under ultraviolet light and you'll understand. It doesn't sparkle, it glows, softly, silently, as if whispering the memory of the stars that made it, and warning you, in the same breath, to step back. Because Torbornite is not meant to be owned, it's meant to be respected. Stone number 28, autumnite, the golden breath of radiation. The hills around Autumn, France, look peaceful today. Quiet farmland, gentle light, and the hum of wind between pines. But in 1852, this landscape gave birth to a discovery that glowed brighter than firelight, autumnite, a luminous yellow-green crystal that marked humanity's first true encounter with uranium's hidden heart. It was here that French mineralogist Henri Becquerel first noticed the mineral's strange behavior under sunlight, a faint, ghostly radiance that refused to fade. Decades later, scientists realized what that glow meant: radioactivity. What had once been mistaken for phosphorescence was, in fact, the mineral releasing atomic energy from within the world had unknowingly stepped into the nuclear age. Autumnite forms in granitic and hydrothermal uranium deposits where oxygen, water, and decay meet its structure. Calcium uranyl phosphate dihydrate is delicate, layered like parchment. Each thin plate carries a subtle, waxy luster that shifts from citron yellow to chartreuse, as though it were sunlight trapped in stone. When miners struck the walls of the autumn quarry, they described veins that glowed like oil lamps underground. It was beautiful and dangerous. The extraction of autumnite was never about jewelry. It was about curiosity, science, and later, power. During the early 20th century, samples from France, Portugal, and the Colorado Plateau were shipped to laboratories, their faint radiation used to calibrate Geiger counters and to refine uranium salts for research. By the 1940s, with the world racing toward atomic energy, autumnite became the face of a new era. one where beauty could split atoms, yet among collectors, its allure endures. Under UV light, autunite glows a neon lemon halo, brighter than any natural mineral. But it's fragile. Exposed to dry air, it dehydrates, fading into a pale powder known as meta-autunite. To preserve it, museums seal specimens in humidity-controlled glass, where they can survive centuries without crumbling. In that controlled darkness, each crystal seems alive, pulsing with quiet light. On the market, true autumite crystals, thin, transparent, perfectly tabular, fetch $500 to $1,500 per piece, though most never leave scientific collections. A few reckless artisans have tried setting it into pendants, encased in quartz or resin, but such attempts are met with sharp criticism. The crystal's surface emits measurable radiation, not enough to harm at a glance, but enough to make time its enemy. Still, to those who've seen it in person, autumite remains unforgettable. Its color is not the warmth of gold or the richness of jade, it's the color of warning, the hue of energy itself. Standing before it, you don't just see the mineral, you feel it, as though the stone is quietly exhaling, sharing the same ancient breath that once powered stars. And so the golden breath of autumite still whispers from the earth. Beauty and danger were never meant to be separate.
Stone number 27. Croquat, the scarlet warning of lead and fire. Deep in the wilderness of Tasmania, Australia, where the mountains are carved by ancient rain and the soil still bleeds red from iron and time, lies one of Earth's most striking yet deadly miracles, croquat. To miners, it was once called the fire trapped in stone. To scientists, it remains a chemical paradox. Breathtaking beauty made of poison, croquat, chemically lead chromate, PbCrO4, forms only in places where lead-rich veins meet oxidized chromium, a union so rare that almost every specimen worth collecting comes from a single site, the Dundas mine in Tasmania, discovered in the mid-1800s. Early prospectors thought they had struck cinnabar or ruby ore, but when they crushed the crystals, they found no gold, no mercury, only a pigment so vibrant it could outshine blood. Those red-orange needles, sharp and glassy, soon became the secret ingredient in chrome yellow and scarlet paints of the Victorian age. The color adorned royal carriages, military banners, even paintings by Turner and Monet. But the painters who mixed it often grew ill, their hands trembling, their skin pale, their lungs failing. The culprit was the lead and chromium slowly seeping into their blood. In raw form, croquat is fragile beyond belief. Its crystals grow as delicate prisms, often hollow, glimmering like frozen sparks. They shatter at a whisper. When struck by light, they blaze with a metallic flame that no camera can truly capture. An inner fire that flickers between crimson, orange, and molten gold. Museum curators handle it with gloves. Never breath near it and never expose it to heat. Under ultraviolet light, it glows faintly, as if remembering the furnaces that birthed it. Extraction is an act of patience and reverence. Modern miners use soft brushes, tweezers, and compressed air to free each crystal from the crumbly matrix of clay and quartz. One careless touch, and months of work vanish into dust. Each perfect specimen is mounted in inert acrylic, sealed away from moisture, because lead chromate is not just toxic when inhaled or ingested, it's also photoreactive, degrading slowly under sunlight. In today's collector market, croquat is a paradox of desire and restraint. Fine clusters from Tasmania can sell for $2,000 to $6,000, their value determined not by size but by the integrity of the needles. How many remain unbroken, how pure their fire. Yet no responsible jeweler would ever cut or wear it. To set croquat against the skin would be to invite the very poison that gives it life. And still, it fascinates. Because croquat tells a deeper story of the Earth's ability to merge creation and destruction in a single breath. It's not a gem for adornment, but for awareness, a monument to nature's warning system, sculpted in scarlet and lead. Stand before it in silence, and it feels almost alive, as if the stone itself is whispering, "I am beauty, but I burn." Stone number 26. Wolfenite, the orange mirror of vanishing suns. In the scorched deserts of Arizona, under skies the color of rust and flame, miners once chased a light that seemed to burn even after sunset. Buried deep in old lead mines near Red Cloud and Los Lamentos, they found sheets of orange glass so vivid they looked molten. This was wolfenite, a mineral so bright it defies shadow, yet born from one of Earth's darkest elements. Lead wolfenite's formula, lead molybdate, binds lead and molybdenum in delicate, wafer-thin crystals that stack like fragile panes of amber. Each one catches the light with a honeyed fire, shifting between tangerine, burnt gold, and deep copper. When you tilt it, it flashes like the wing of a monarch butterfly, and then disappears, swallowed by its own translucence. Discovered in the late 18th century and named after Austrian mineralogist Franz Wolfen, the stone first appeared in the Bleiberg mines of Carinthia, high in the Alps. But it was the Arizona specimens over a century later that stunned the world. Tabular crystals so thin they could flutter in air currents. The miners called them sunset shards. They handled them with reverence, knowing one wrong breath could shatter a year's fortune. Extraction of wolfenite requires artistry, not machinery. The best specimens are unearthed with brushes and wooden picks, washed only with distilled water, then sealed in glass boxes to prevent oxidation. Every mine that yields it, Red Cloud in the US, Sumeb in Namibia, Mfwati in Congo, becomes a shrine of color against the dull gray of lead ore. But like many of Earth's fiery beauties, wolfenite hides a darker core. The lead content makes it unsafe for prolonged handling, and when ground or heated, it releases toxic dust and fumes. Lapidarists refuse to cut it. Jewelers admire it only through barriers, and museums treat it like living flame. Dazzling, untouchable, sacred still, collectors pay handsomely for it. Perfect red cloud crystals, square and glass clear, can fetch $1,500 to $5,000 apiece. The finest, paper-thin plates, flawless and balanced, are considered crystals of equilibrium, symbols of impermanence. Because wolfenite doesn't last forever. Exposed to sunlight, it fades. Exposed to air, it dulls. It is, by its very nature, a vanishing gem, a mirror of the sun's final color before darkness. In the language of geologists, wolfenite represents transition, a mineral born at the dying edge of ore deposits, a sign that a mine's richest days are over. To find it is to stand at the threshold between abundance and exhaustion. Perhaps that's why it feels so emotional to behold. It's not just beauty, it's farewell. The Earth's last glimmer before the light runs out. Hold it to the light, and you'll see what ancient miners saw. A perfect sunset, caught forever in crystal, and already beginning to fade. Stone number 25, hydrazine, the ghost mineral of silent corrosion. Beneath the collapsed roofs of old zinc mines in Sardinia, Greece, and New Mexico, a faint white shimmer clings to the stone walls, like frost that refuses to melt. But this is no ice. It is hydrazine, the ghost mineral that forms when time itself begins to eat away at metal. Chemically, it is Zn5 open parenthesis, CO3 close parenthesis, 2 open parenthesis, OH close parenthesis, 6, a basic zinc carbonate that appears only when zinc ores decay under air and moisture. To a casual observer, it looks like chalk or ivory dust. But under UV light, hydrazine glows with an eerie blue-violet luminescence, as if the mine were haunted by its own breath. Miners once brushed it from their tools, not realizing they were disturbing one of the Earth's most delicate alchemical transformations. The moment when raw zinc oxidizes, cools, and crystallizes into powdery bloom. The surfaces it coats, smithsonite, hemimorphite, galena, seem to age before your eyes as though nature were painting over its own scars. In the Laurium mines of Greece, hydrazine is found as velvety coatings over ancient slag heaps, remains of the world's first metal smelters. Dating back over 2,000 years, archaeologists describe it as the mineral that remembers smoke. It's not mined for beauty. It simply appears, whispering that metal never truly dies. It transforms, leaving pale fingerprints of corrosion behind collectors prize it for that spectral look. Soft, chalky white clusters resembling moon milk or bone dust, often growing in delicate botryoidal forms. But its fragility makes it almost impossible to handle. Even a fingertip's warmth can leave marks. A breath can scatter it. In museums, curators mount it in sealed acrylic boxes under low light, both to preserve the glow and to prevent inhalation of zinc-rich particles, which, though less toxic than lead or arsenic, can still irritate lungs and skin. Hydroxyensite has no jewelry value. It cannot be cut or polished. Yet its symbolic worth is immense. In the language of mineralogy, it represents impermanence, the slow surrender of metal back to air. For geologists, it's a clue that a once-living mine is reaching its quiet end. For collectors, it's a meditation, the reminder that even minerals, which seem eternal, fade. Still, the market finds beauty in its frailty. Rare, well-formed specimens from Laurium, Namibia, and Sardinia can sell for $200 to $800, depending on purity and fluorescence. The most sought-after pieces are those that shimmer faintly under UV, the sleeping lights, as curators call them. Under the camera lens, hydroxyensite looks like frozen breath. Under the microscope, like galaxies of dust. It is the poetry of entropy, beauty dissolving in silence. And when you stand before it, in the dim blue glow of a museum vault, you realize it is not a stone meant to last. It is a reminder that everything, even light, eventually turns to powder.
Stone number 24, smithsonite, the pastel alchemy of deception and decay. In the silent mountains of Namibia and Mexico, old miners used to whisper about a stone that deceived them, a gem that shimmered like turquoise but hid a miner's curse beneath its charm. That stone was smithsonite, the pastel alchemist of the mineral world. Its name honors James Smithson, the English chemist whose studies in the late 1700s revealed its true nature. Not turquoise, not chrysocolla, but zinc carbonate, ZnCO3. Before him it was confused for hemimorphite. Both grew in the oxidized shells of zinc ore, forming silky crusts that blurred the line between rock and skin. Smithson's discovery didn't just separate two minerals, it rewrote the story of zinc. Geologically, smithsonite forms where galena, sphalerite, and calcite decay through centuries of oxidation. It's the mineral of afterlife, born when other ores surrender to air and water. The mines that produce it, Tsumeb in Namibia, Kelly Mine in New Mexico, Laurium in Greece, and Schwa in Mexico, are more like necropolises than quarries, layers of dead metals reborn into color. And what color? Smithsonite wears every shade the earth has ever breathed: mint green, lavender, rose, sky blue, lilac, lemon, ivory, even pink gray. Each hue comes from impurities that lend it identity: copper for blue, cobalt for pink, cadmium for yellow, and iron for green. Polished spheres look almost edible, their silky luster glowing like wet porcelain. Under soft light, they seem alive, like soap bubbles frozen mid-motion. But the beauty is deceptive. Behind its gentle face lies a mineral that breathes toxicity. The zinc content, harmless to glance at, becomes hazardous when dusted, heated, or inhaled. Old miners who crushed the ore to extract zinc oxide, the same compound used in medicine and paint, learned too late that metallic fumes could scar their lungs forever. Modern lapidaries approach it like handling sleeping mercury. They polish underwater, behind glass shields, and never heat the stone. In jewelry, only cabochons sealed in resin are considered safe, and even then, contact with moisture or sweat can dull the surface over time. It's the kind of gem that demands distance, admiration without touch. Still, smithsonite remains a collector's delight. Exceptional specimens, translucent botryoidal masses from Tsumeb or Kelly Mine, command $800 to $3,000, while museum-grade pieces can exceed $10,000. Ironically, its value rises not for perfection, but for imperfection, for the delicate cracks, blended colors, and weathered texture that marks centuries of geological transformation. Under magnification, you can see tiny scars, microscopic rivers where zinc once leached away, leaving pale veins like fingerprints of time. Each one tells the same truth. Beauty is not born of youth, but of endurance. So when light slides across its pastel skin, smithsonite doesn't just shimmer, it sighs, a soft, ancient exhale from the earth itself. Stone number 23, uraninite, the black heart of radiation. In the cold, silent tunnels beneath Joachimsthal, Bohemia, miners once unearthed a stone darker than coal, heavier than iron, and stranger than anything they had ever seen. It glistened faintly, not with reflected light, but with a ghostly radiance that seemed to come from within. They called it pitchblende, meaning the deceptive ore. Today, we know it as uraninite, the black heart of radiation, composed primarily of uranium dioxide, UO2. This mineral is the Earth's most concentrated source of natural uranium, the element that would one day power cities, level them, and alter the balance of civilization forever. But long before the atomic age, uraninite was a mystery. In the 1500s, Bohemian miners smelted it, hoping for silver. Instead, they found only heavy slag and sickness, burns, sores, and coughing that no one could explain. Centuries later, in the late 1800s, scientists finally understood what the miners had stumbled upon. From the tailings of Joachimsthal's mines, Marie and Pierre Curie isolated radium, the glowing child of uraninite. That discovery won them a Nobel Prize, and tragically, cost them their health. The faint light that fascinated them was the soft whisper of atomic decay. Geologically, uraninite forms deep within granitic pegmatites and hydrothermal veins, where uranium-rich fluids cool and crystallize under immense pressure. The result is a dense, metallic black mass that often shows subtle sheens of bronze, gray, or oily green. When freshly broken, its surface reflects light like obsidian, but over time, exposure to air alters it. Oxidation turns it into a crust of yellow and green secondary minerals such as automite, torbernite, and meta-uranocerkite, each glowing with quiet menace. Handling uraninite today is an act of reverence and precision. In research labs, it is stored behind lead glass, measured with Geiger counters, and handled only by gloved hands. Even the smallest sample emits steady radiation, a heartbeat from the Earth's deep core. Some museums keep their specimens in sealed vaults, not for beauty, but for containment, yet collectors still seek it, not out of greed, but awe. To hold uraninite, even briefly, is to hold the raw material of both creation and annihilation. Economically, it is paradoxical. A stone worth both millions in refined form and nothing in art. It will never be set into jewelry, never worn on skin. Instead, its price lies in potential, in the energy it can release when its atoms are split. Each gram contains the fire of 1,000 suns. Each crystal is a reminder that the Earth's darkest stones often hold the brightest power. Look closely at a polished fragment under light, and you'll see a faint metallic glow, the echo of energy still unfolding after 4 billion years. It is beautiful, yes, but it is beauty with consequence. In every sense, uraninite is not a gemstone. It is a threshold, the moment the mineral world crosses into myth, because this is not just rock, it is the Earth's pulse, still burning. Stone number 22, uranocercite, the radiant relic of vanishing light. In the quiet valleys of Saxony, Germany, there lies a mine that no longer sings with picks or echoes with footsteps. Its tunnels are sealed, its entrances marked with radiation warnings, and yet, if you shine a faint beam of light into the darkness, something still glows back. That ghostly shimmer belongs to uranocercite, the forgotten sibling of torbernite and automite, a mineral that once captured the Earth's breath of radioactivity in delicate yellow-green plates. Chemically, uranocercite is Ba-UO22PO4 2x10 H2O, a hydrated barium uranyl phosphate. In simpler words, it is uranium's quiet afterglow, formed when uranium-bearing fluids meet barium-rich rock veins in granitic crusts. Its crystals grow in wafer-thin sheets, often arranged like overlapping feathers, glowing softly even in dim light. Under ultraviolet, it transforms into a miniature sunrise, a vivid canary yellow with hints of emerald fire, so bright it almost appears artificial. Discovered in the late 1800s near Schneeberg, Saxony, uranocerkite was initially prized by collectors for its luminescence. Miners would bring samples home to their children, who placed them on windowsills to catch starlight. No one understood that the glow was not a reflection. It was the slow, steady release of radiation. Over decades, those playful gifts darkened, crumbled, and vanished, leaving only dust. Extraction of uranocerkite is a race against time. The mineral is highly unstable, losing water molecules even at room temperature. Without protection, it dehydrates into meta-uranocerkite, fading like a dying ember. That fragility makes every surviving crystal a small miracle. Modern mineralogists collect it only under strict safety conditions: gloves, masks, and sealed containers. The most perfect specimens, paper-thin, translucent, still vibrant after decades, are stored in radiation-safe humidity chambers, their colors monitored like living tissue. To the eye, uranocerkite looks peaceful, like sheets of frozen sunlight scattered on gray granite. But the peace is deceptive. Its radioactivity, though weaker than pure uraninite, is constant. It hums softly on a Geiger counter, a quiet pulse from the Earth's core. In museums, curators stand behind leaded glass to examine it, and in private collections, only the bold or the reckless keep it close. Yet the allure persists. To collectors, uranocerkite represents the meeting point between life and decay, the moment when energy solidifies into beauty. Its market value ranges from $400 to $1,200 depending on size and fluorescence, but its true worth lies in symbolism. It is the mineral of impermanence, beauty that glows brightest just before it fades. Under a microscope, the crystal reveals a lattice of fractures, each one a frozen snapshot of atomic disintegration. What we see as color is really time breaking apart, and that is uranocerkite's paradox, a stone that glows not by reflecting light, but by dying in light. Stone number 21, Hutchinsonite, the thallium whisper of the deep high in the narrow valleys of Switzerland's Bin Valley and deep inside the forgotten mines of Peru. Miners once unearthed a mineral that looked like nothing more than tangled strands of black metal, thin, fragile needle-like crystals woven through pale rock like burnt hair. But when a lantern struck it, a faint red shimmer appeared, a warning glow. This was Hutchinsonite, the mineral where three poisons meet: thallium, lead, and arsenic. Chemically written as TlPb22s5s9, it is a sulfosalt born in low-temperature hydrothermal veins, but in human terms, it is death crystallized. Thallium, the most feared of the three, is so toxic it was once used in rat poison, capable of killing in milligrams, able to enter the bloodstream simply through touch. Arsenic, of course, is history's silent killer. And lead, the slow metal, destroys the body one organ at a time. Hutchinsonite binds them together like a woven curse. To the eye, however, it's mesmerizing. The crystals form delicate sprays of metallic needles, flashing red, black, and wine-colored highlights when turned under light. Some grow in dense forests of hair-thin blades. Others radiate outward like the frozen explosion of a star. Under a microscope, the mineral looks alive, like fine strands of muscle or nerve tissue petrified mid-motion. But beauty here is a trap. The crystals are brittle. A single touch can snap them into dust. And that dust, invisible, weightless, carries thallium. Early miners didn't know. They broke samples barehanded, wiped sweat from their faces, dusted their gloves on their clothes. Days later came the symptoms: numb fingertips, hair falling out, burning lungs, weakness in the legs. Thallium poisoning doesn't shout, it whispers, slowly, quietly shutting down the body. Many miners never knew the source. Today, Hutchinsonite is collected only by experts, and always with gloves, masks, and sealed containers. Museums store it under airtight glass. Curators avoid even the tiniest fracture, because if thallium dust escapes, the danger is real. Not dramatic, not theatrical, but biological. Despite the risk, its allure remains powerful. Natural, undamaged specimens from Switzerland or Peru, with long, sharp, intact needles, can sell for $1,000 to $4,000. Not because they can be worn or displayed openly, but because they represent something rare, a mineral that is both scientifically remarkable and profoundly unforgiving. Hutchinsonite is not a gemstone. It is a boundary, a line between admiration and caution. It reminds us that some of Earth's most beautiful creations were not made for human hands. Stand before it, behind the safety of glass, and you'll see the truth. Those red-black needles do not sparkle. They warn, a mineral that whispers softly, "Look, but do not touch." Stone number 20, tremolite. The ghost veins of the earth. High in the Italian Alps and deep within the Canadian Shield, the Marble Mountains breathe a strange mist when split open. Inside their pale veins, something glints like frozen smoke. Long, silky fibers, soft as hair, yet sharp as glass. This is tremolite, one of the most haunting minerals ever found. The ghost that hides inside stone. At first glance, tremolite looks innocent. A shimmering mineral in shades of white, gray, pale green, or translucent silver. Its fibers seem delicate, almost angelic, twisting like strands of moonlight, but behind that beauty lies one of geology's deadliest secrets. Tremolite belongs to the Amphiboly family, and in certain forms it transforms into asbestos, a mineral once hailed as miraculous, later cursed as lethal. Chemically, it is calcium 2-magnesium 5-silicon 8-oxygen 2,2-hydroxide 2, a silicate born from metamorphosed dolomite and marble under immense heat and pressure. Each needle-like crystal forms slowly, aligning into silky bundles that can stretch for centimeters. Perfect geometry, perfect danger. In the 19th century, miners in the Italian Alps used to pull it from white marble walls by hand, weaving the fibrous strands into lamp wicks and insulation. They called it stone wool. It wasn't until decades later that doctors noticed the pattern, the coughing, the breathlessness, the invisible fibers lodged deep in lungs. Tremolite's dust doesn't just float, it lingers. Once inhaled, its microscopic shards embed themselves into tissue, triggering asbestosis, lung cancer, and mesothelioma, often decades after exposure. The same mineral once admired for purity had become a silent killer. Today, tremolite is handled with the caution of nuclear material. In geological labs, it's viewed only under sealed microscopes. Miners avoid the veins that carry it. Even museum curators refuse to display loose fibrous samples. Instead, they seal them behind airtight glass, labeling them not as gems, but as hazards of history. Yet, paradoxically, in its solid, compact, crystal form, where fibers are locked within rock, tremolite is stable, safe, and mesmerizing. Crystallized tremolite can form striking transparent blades, faintly green or milky white, often found in Tanzania, Pakistan, and Canada. Under polarized light, it glows like shards of frozen air gem cutters. When daring enough, slice only the compact pieces, never fibrous, into cabochons that gleam like glacier ice. A flawless crystal may sell for $600 to $2,000, though few dare to work with it. To the archaeological eye, tremolite tells a tragic dual story of nature's artistry and humanity's hubris. It is both medicine and poison, sculpture and specter. Ancient civilizations unknowingly carved it into idols, believing the silky fibers symbolized purity. Today, scientists wear respirators to study those same statues. Under magnification, tremolite looks alive. 1,000 threads of silver, interwoven like muscle fibers of the planet itself. Beautiful, lethal, eternal. And as the light hits its surface, one truth becomes clear. The earth doesn't divide beauty from danger. It weaves them together, strand by strand, breath by breath, until even the air remembers what it touched. Stone number 19. Galena, the mirror of darkness. In the forgotten tunnels of Derbyshire, England, the walls still glitter as if lined with tiny mirrors centuries ago. Miners carried lanterns through the dark, and every beam of light fractured into 1,000 reflections. Silver, sharp, and cold, they called the ore galena, the lead mirror, for its uncanny ability to shine like polished metal even in the deepest black. But what they were really looking at was death. Disguised as beauty galena, lead sulfide, PBS, is one of humanity's oldest minerals. It was mined in Egypt, Greece, Rome, and China for over 4,000 years, smelted into lead for pipes, paints, and bullets. The ancient Egyptians ground it into a fine powder called kohl, using it to darken their eyes against the desert sun. Queens, pharaohs, and priests wore that shimmer daily, not knowing that every brushstroke carried microscopic poison. In the mines, galena appears as cubic crystals so perfect they look carved by design. Their color is a liquid gray-black, their faces flat and flawless enough to reflect your image. To the archaeologist's torch, they gleam like obsidian, yet heavier, denser, almost greedy with gravity. Pure galena is 86% lead by weight, one of the densest natural materials on Earth. Hold a small piece, and it feels impossibly heavy, as if it wants to sink back into the planet that birthed it. The beauty of galena deceived generations in the Roman Empire. It was the lifeblood of plumbing and currency, the very veins of civilization, yet it was slowly poisoning the empire from within. The water running through lead pipes, the makeup glistening on noble faces, even the wine sweetened with lead acetate, all of it traced back to these gray cubes of glittering ore. Today, galena is still mined in Missouri, Peru, Australia, and China, but with far greater care. Workers wear respirators, ventilation systems hum through the tunnels, and every ounce of dust is treated as toxic waste. Even so, the danger remains. Touch it too often, breathe it too long, and the metal seeps through the skin, silencing the nervous system in slow motion. Yet for collectors, galena remains irresistible. A flawless cubic cluster from the Sweetwater mine in Missouri or the Dalnogorsk mines in Russia can sell for $400 to $2,000, prized for its symmetry and metallic luster. Some clusters form mirror cubes, so precise that photographers use them to reflect studio lights, capturing nature's own geometry. But no jeweler dares to wear it. Galena is too soft, too heavy, too cursed. It is admired at a distance, sealed under glass, a relic of the price civilization once paid for shine under the microscope. Each face of galena tells a story of duality, beauty that blinds, progress that poisons, and as the light fades from its silver surface, what remains is not reflection, but warning. The Earth has always known how to build mirrors. It's humanity that keeps mistaking them for windows. Stone number 18. Zoisite, the mineral of transformation and fire. High in the shadow of Mount Kilimanjaro, where the clouds drift like ghosts over blue-gray rock, lies a mineral that changed the way the world sees color and risked the health of those who unearthed it. Its name is zoisite, the parent stone of the world-famous tanzanite and one of nature's quiet shapeshifters, beautiful, unstable, and born from the Earth's own metamorphosis. Zoisite, K2, Al3SiO4Si2O7OH, forms in metamorphic rocks, where limestone and aluminum-rich fluids fuse under immense heat and pressure. The result is a crystal that seems to hold a pulse of its own, dense, fibrous, and vibrant. Its color palette is extraordinary: green, pink, yellow, blue, violet, or gray, depending on trace elements. The most famous variety, tanzanite, glows a trichroic fire: blue from one angle, violet from another, red from a third, like looking into 3 sunsets at once. But behind that radiance lies danger. When heated to intensify its hue, a common practice, zoisite releases toxic aluminum and silicate dust. In mining villages near Marilani Hills, Tanzania, local workers have long reported lung scarring and chronic respiratory problems from years of cutting and grinding the gem without protection. The same mineral that made fortunes also carved silent wounds. Raw zoisite crystals are coarse, rugged, almost volcanic in texture. Under a knife, they flake into razor-thin splinters that shimmer faintly in sunlight. When polished, their surfaces transform, a silky, waxy sheen that feels alive, as though light is flowing beneath the skin. The duality is mesmerizing, one side chaotic and raw, the other refined to perfection. Historically, zoisite was first described in Austria's Saalpe Mountains in 1805, where it appeared as dull green masses, unremarkable until gemologists realized its potential for color change under heat. It wasn't until the 1960s that its Tanzanian cousin stunned the gem world, turning zoisite into a global phenomenon. Tiffany & Company renamed it Tanzanite to make it more marketable, but beneath every cut gem still lies zoisite's true nature, a metamorphic survivor shaped by volcanic fire. For collectors, unheated zoisite specimens from Austria, Pakistan, or Tanzania sell for $300 to $1,500, depending on clarity and color zoning. The rare chrome-rich green variant, aniolite, interlaces zoisite with deep ruby crystals, creating a contrast so vivid it looks painted by hand. Yet even these marvels must be handled gently. Under grinding tools, zoisite's fine silica dust can irritate lungs and eyes, and in powder form, aluminum ions can leach into water, making it a mineral of both wonder and caution. To the trained eye, zoisite is more than gemstone ore. It's a geological biography. It records every stage of pressure, heat, and fracture. Every facet tells of transformation, from dull stone to brilliance, from danger to beauty. And so, beneath Kilimanjaro's silent slopes, zoisite continues to glow in the dark, not as a gemstone, but as a reminder that all transformation comes with cost, because even beauty, when born from fire, must carry its scars. Stone number 17. Amazonite, the deceptive calm of the Green River stone. Along the banks of the Amazon River, the jungle hums with mist and mystery. Traders once believed a green stone washed up by the current came from deep beneath those waters, a gift from the gods of the forest. They called it Amazonite, but the truth was stranger. It had never been found near the Amazon at all. The name, like the stone, was an illusion. Amazonite, a vivid green to turquoise variety of microcline feldspar, Calzi 308, forms in granite pegmatites, not riverbeds. The best specimens emerge from Colorado, Madagascar, and Russia's Ilmen Mountains, shimmering like jade under sunlight. Ancient peoples carved it into beads, talismans, and ritual blades. In Egypt, it was laid into the jewelry of Tutankhamun, believed to cool the heart and steady the spirit. But what the ancients never knew, and what modern science now warns, is that the color of Amazonite comes not from serenity, but from trace amounts of lead and water-bound copper. That's right, the same metal that poisoned Rome gives Amazonite its celestial hue. Its signature blue-green glow is the result of lead ions trapped in the feldspar's crystal lattice, scattering light in microscopic fractures. Handle it roughly, or grind it, and that beauty turns dangerous. The dust carries lead silicate particles that can enter the bloodstream through the lungs or skin. Lapidarists who polish it dry risk slow, invisible poisoning. The stone that soothes the soul can quietly harm the hand. Still, its surface remains mesmerizing. Amazonite's texture is soft, almost waxy, with a gentle shimmer called schiller, a play of light across interlocking feldspar crystals. When cut and polished, it reflects like calm water under sunlight. That optical calm has made it a favorite for sculptors, who carve it into amulets and ritual figurines that seem to breathe tranquility. Yet beneath that piece lies the geological memory of tension, each green fracture a scar of the Earth's slow cooling extraction. Today happens mostly in Pikes Peak, Colorado, where miners split granite veins by hand to preserve the stone's integrity. A perfect specimen, translucent, patterned with faint white striations, can fetch $200 to $1,200, while large museum-grade clusters reach higher. Jewelers often coat it with resin to seal away the lead and prevent fading, turning raw danger into wearable beauty. Culturally, Amazonite is still marketed as the stone of courage and truth, said to calm nerves and balance energy. But perhaps its truer symbolism lies in contradiction. That harmony often hides volatility, and that peace is never pure without awareness. Under polarized light, Amazonite reveals its secret, alternating bands of blue and green, like a heartbeat frozen in crystal. To look at it is to stare into still water and sense the current beneath. And as every geologist knows, calm rivers always hide their deepest pull. So remember the lesson of Amazonite: the most tranquil stones are often those that learn to survive chaos. Stone number 16. Amber. The fossilized sunlight of forgotten forests. In the windswept shores of the Baltic Sea, after a storm has torn through pine and salt and foam, locals still walk the sand at dawn, searching for gold that floats. What they find is not metal, but memory, hardened sunlight, washed up from a forest that no longer exists. This is amber, the stone that isn't stone at all. Amber is the fossilized resin of prehistoric conifer trees formed between 30 and 90 million years ago. Each drop began as a tear, tree sap bleeding to seal a wound, and over eons it hardened under pressure and time until it became translucent gold. Some pieces are so pure they glow like fire trapped in honey. Others hold entire worlds, frozen insects, moss, air bubbles, even raindrops from the age of dinosaurs. Its geography spans the world: Baltic coasts of Poland and Lithuania, Dominican jungles, Myanmar's Hukong Valley, and Siberia's riverbeds. Each region's amber has its own signature: Baltic amber, warm and golden; Dominican amber, transparent blue; Burmese amber, deep red like ancient wine under ultraviolet light. It fluoresces with a ghostly green flame, proof that what you're holding was once alive. But not all that glows is harmless. Modern studies reveal that amber, especially when heated, burned, or drilled, releases toxic fumes of succinic acid, formaldehyde, and carbon compounds. Ancient jewelers didn't know this when they carved and polished it in open-air workshops. The smoke that filled their lungs carried sweetness and poison in equal measure. In the Middle Ages, amber was burned as incense to ward off disease. Yet the fumes it produced irritated eyes and throats. Inhaling it too often could scar the lungs permanently. Even in modern times, amber's fragility poses danger. When exposed to flame or acid, it softens, melts, and releases flammable gases. Museums store it in cool, dry vaults. Wrapped in darkness to prevent cracking, lapidarists must work it under water or oil, never dry, to avoid both dust and fumes. And yet, people still wear it, drawn to its warmth, its history, its illusion of safety. In the collector's world, amber's price depends not on clarity alone, but on its secrets. A perfect golden cabochon might sell for $200 to $1,000, but a piece holding a prehistoric insect, a fly, an ant, or a lizard tail can reach tens of thousands of dollars. Each inclusion is a fossilized moment, a creature caught mid-breath, preserved forever by accident under magnification. The surface of amber looks alive, rippled like melted honey, lined with faint flow marks that once carried scent and sap. When you hold it up to the sun, it almost glows from within, as if remembering what it once was. Amber is time, petrified. It hums softly with nostalgia, a golden echo of trees that whispered to dinosaurs. And if you listen closely, you can almost hear it breathe, the sound of the forest, trying to wake again. Stone number 15. Adamite, the poison that glows like joy. Under the relentless sun of Ojuela Mine, Mapimi, Mexico, the desert wind howls through tunnels carved a century ago. Deep inside those orange cliffs, the walls shimmer with colors too bright to belong underground: electric yellow, apple green, even golden honey that seems to hum in the dark. This is adamite, the mineral that glows like joy, yet carries the breath of death. Adamite, chemically, Zen2, ASO4OH, is a zinc arsenate hydroxide, a fragile compound of zinc, oxygen, and arsenic. It forms in oxidized zones of zinc and arsenic ore deposits, usually in abandoned or drying mines where air, water, and decay meet. When torchlight hits its crystals, they ignite in fluorescence, an otherworldly lime glow that feels almost alive. To miners who first saw it in the late 1800s, adamite was a miracle of color. They didn't know it was laced with one of Earth's oldest poisons. The Ojuela mine became legend because of it. Its cavern walls bloomed with radiant fans and clusters of transparent prisms, some so delicate they collapsed under their own weight. Miners compared them to frozen sunbeams, yet as they drilled deeper, they began to fall ill, coughing, trembling, their fingernails turning pale blue. The dust they inhaled carried arsenic oxide released from adamite's breakdown. They were dying by the same beauty they admired. Today, adamite still dazzles collectors and museums alike. Its fluorescent color under ultraviolet light is one of the most vivid in the mineral world, pure neon yellow-green, as if the stone stores its own lightning. Under the microscope, its structure reveals triangular crystal lattices so symmetrical they seem designed by an artist. The surfaces sparkle with glassy luster, sometimes veined with deep violet or rust from iron staining. But despite its beauty, handling it requires precision and respect: gloves, masks, sealed storage, and no water contact. When damp, adamite can leach arsenic into its surroundings, invisible, tasteless, and deadly. It's mined now only for science and display, not for jewelry. The mineral is too soft, Mohs 3.5, too brittle, too toxic. Still, a perfect cluster from Ojuela or Greece's Lavrian mines can sell for $800 to $2,500, depending on color saturation and fluorescence. The rare cobalt-rich purple adamite, a chemical cousin, fetches even higher prices. But even collectors handle it like a relic, not a gem. The slightest grinding or heat could awaken its hidden breath. Culturally, adamite has earned a paradoxical reputation, a stone of creativity, said to energize the mind, though in reality it silences it. Its glow, hypnotic and joyful, conceals the same arsenic used in pigments, poisons, and old medicines. To the poetic eye, it's the perfect metaphor: beauty that betrays, light that deceives. When you stand before a specimen in a darkened museum, under a UV lamp, adamite's glow seems to move, as if it's breathing. But that pulse is radiation, the slow decay of elements trying to become something safer, and that is its story, the shimmer of life, born from death, the kind of beauty the earth creates not to be worn, but to be remembered. From a distance. Stone number 14, actinolite, the green breath of stone. High in the alpine valleys of Switzerland and British Columbia, the mountains glisten with veins of dark green rock that seem to flow like frozen rivers. To ancient carvers, this was a form of jade, smooth and beautiful, perfect for blades and ornaments. To geologists today, it is a name spoken with caution: actinolite, the mineral that breathes danger into dust. Chemically, actinolite is calcium, magnesium, iron, 5-silicon-8, oxygen, 2,2-hydroxide 2, a member of the amphibole family, the same family that gave the world asbestos. In its solid, compact form, it's stunning, a deep green or black crystal with a silky, fibrous sheen, radiating light like frozen moss. But when its fibers grow long and thin, the dreaded asbestiform variety, actinolite becomes something else entirely: invisible, airborne, and lethal. For centuries, ancient artisans carved actinolite into tools, pendants, and ceremonial idols. In China and Burma, its dense, jade-like texture was considered sacred. Warriors wore it for strength. Priests used it in purification rituals. But none knew that the beauty they polished was woven with microscopic blades. When heated, drilled, or cut, actinolite releases fibers thinner than a human hair, indestructible shards that float through air and lodge deep inside the lungs. Once inhaled, they stay there for life. Modern science calls this the asbestos curse. The same mineral that builds strength in stone destroys strength in flesh. Exposure can cause asbestosis, lung cancer, and mesothelioma, often decades after the first breath. Mining towns that once celebrated actinolite in Quebec, Italy, and the Alps now stand abandoned, their air too dangerous to breathe. The echoes of pickaxes have been replaced by silence and warning signs, and yet the paradox remains. Pure, compact actinolite, the non-fibrous kind, is breathtaking. It forms elongated prisms or needle clusters, translucent in thin sections, glowing between emerald and bottle green. Under light, it looks alive, like the veins of a leaf trapped in stone. Some polished cabochons are still sold, though carefully labeled non-asbestiform. Jewelers handle them with gloves. Lapidarists grind them underwater to keep the fibers from rising. In the collector's world, specimens from Pakistan, Tanzania, and Switzerland fetch $200 to $1,000, depending on clarity and color. The rare cat's eye actinolite, a fibrous yet stable form, shows a bright silver line under light, a perfect illusion of safety. But true experts know the truth. Beauty and risk grow from the same root. To the archaeologist, actinolite is more than a mineral. It's a reminder of humanity's pattern to worship what later wounds us. In museum vaults, sealed under glass, the shimmering fibers still look alive, swaying like seaweed under the lens. Even in death, the stone seems to breathe, and that is the paradox of actinolite, a mineral that gave shape to sacred art and later gave rise to ghosts. Because not all dangers roar, some drift quietly in the air between beauty and breath. Stone number 13. Apatite, the deceptive twin of bone and ocean. On the coasts of Madagascar and deep within the limestone caverns of Brazil, miners sometimes strike veins of blue that look like fragments of tropical sea, translucent, glowing, impossibly calm. It is apatite, a gemstone so beautiful it's easy to forget that it shares its structure with our own skeleton, and, like us, it can fracture under pressure. Chemically, apatite is Ca5, PO43F, CalOH, a family of phosphate minerals found everywhere from coral reefs to meteorites. The very word apatite comes from the Greek apateion, meaning to deceive, because it mimics so many stones: topaz, beryl, aquamarine, peridot. But this deceiver carries a hidden edge. When fractured, cut, or ground, apatite can release fine fluoride and chlorine-bearing dust, irritating the lungs and, in large doses, attacking the nervous system. The same fluoride that protects teeth in trace amounts becomes a slow toxin in abundance. To the eye, however, apatite is pure serenity. It crystallizes in hexagonal prisms, glowing in shades of sea blue, lemon yellow, and emerald green. The most coveted variety, neon apatite from Madagascar, shines with an electric turquoise so intense it looks backlit. In dim light, the crystals seem to pulse, like captured ocean waves. Ancient traders along the Red Sea and Indian coasts once sold it as waterstone, believing it could purify the body. They never realized that when carved and polished, its dust could harm the lungs of the very artisans shaping it. In the 19th century, apatite became both a gemstone and a fertilizer ground into powder. It released phosphorus vital for plant growth. The same element that nourishes life also makes up human bones and teeth, an eerie kinship between flesh and mineral. That connection fascinated early biochemists. We are, in a literal sense, built from the same lattice as apatite, yet in mining towns from Mexico to Morocco, the dust that fed crops also scarred the lungs of miners, etching a cruel irony into progress. Under ultraviolet light, apatite reveals ghostly fluorescence, pale green and violet halos flickering around its edges. In gem form, it's fragile, Mohs 5, easily scratched and broken. But its vibrance makes it irresistible to jewelers, who often set it in sealed glass or gold to prevent skin contact. Fine faceted stones from Madagascar or Brazil can fetch $300 to $1,200, while rare violet or pink crystals from Myanmar climb higher. To hold apatite is to hold a mirror to both ocean and bone, to the cycle of calcium, phosphate, and life itself. It's the mineral embodiment of transformation. Seashell to soil, soil to grain, grain to flesh. And perhaps that's why its danger feels poetic. The same compound that sustains all living things can also remind us how fragile we are within it. Under the microscope, its surface ripples like water caught in glass. Tiny inclusions scatter light like plankton under moonlight. It is calm, alive, deceptive, a reminder that even the ocean, in silence, can drown. Apatite's beauty lies not in safety, but in surrender. It teaches one truth older than life itself. The earth never separates creation from consumption. It simply disguises one inside the other. Stone number 12. Fluorite, the rainbow that breathes acid. In the limestone caverns of Derbyshire, England, when the lantern light meets the rock walls, they bloom into impossible colors: violet, blue, green, and gold, stacked like stained glass windows in the dark. This is fluorite, the mineral once worshipped as the solid rainbow. To ancient miners, it was beauty made visible. To modern science, it is the quiet source of an invisible danger, a stone that breathes acid when disturbed. Fluorite's chemistry is deceptively simple: calcium fluoride, CaF2. Yet within that simplicity lies power. When heated, cut, or ground, it can release hydrogen fluoride gas, one of the most corrosive substances on Earth, capable of eating through glass, flesh, and bone. The same compound that gives fluorite its perfect transparency also hides this volatile secret. Ancient Roman carvers, unaware of the risk, used it to craft wine cups that shimmered like ice. Legend says Emperor Nero owned a goblet carved from purple fluorite, prized above gold. The artisans who shaped it did not live long. Geologically, fluorite forms in hydrothermal veins and limestone cavities, often with quartz, galena, and sphalerite. Its cubic crystals grow in geometric perfection, sharp-edged, translucent, often banded in layered colors. Under ultraviolet light, it glows in vivid blues or greens, a phenomenon that gave birth to the very word fluorescence. To the eye, it seems almost alive, shifting color as the light moves, a prism carved by time. For centuries, fluorite was mined as a flux in metallurgy, helping metals flow during smelting. The Latin fluere, to flow, gave it its name. But those same furnaces that melted steel also vaporized fluoride gas, leaving invisible scars in miners' lungs. In the early 1900s, workers in British and Chinese mines reported coughing fits and brittle bones, symptoms of fluorosis caused by chronic fluoride exposure. Beauty once again came with a hidden cost. Today, fluorite is both adored and feared. Its aesthetic range is unmatched, from deep purple and royal blue to honey yellow, sea green, and colorless crystal. Some pieces show all hues at once, rippling like frozen auroras. Museums display them under rotating light to mimic sunrise and dusk within the stone. Yet behind the glass, safety protocols remain strict. No heat, no moisture, no bare handling. A crack, a polish, a flame, and the air might turn hostile. On the market, gem grade. Fluorite is affordable yet revered, selling for $100 to $600, while extraordinary rainbow cubes from China or Illinois reach over $2,000. But jewelers' fluorite is always sealed. Its fragility and fumes make it a stone admired, not worn. To the archaeologist, fluorite is a paradox carved into mineral form, both a teacher of light and a warning against curiosity. Under the microscope, its edges appear soft, melting like watercolor, as if the stone is trying to dissolve back into light itself. It's said that fluorite carries clarity, but clarity has a price. The more transparent it becomes, the more dangerous it is to touch, because fluorite reminds us that even rainbows have shadows, and that some colors are meant to be seen, never breathed. Stone number 11. Azurite. The blue blood of the earth beneath the desert sun of Morocco's Atlas Mountains. The rocks open like veins of midnight sky inside. Crystals shimmer in royal blue, rich, electric, and impossibly deep. This is azurite, the stone that ancient civilizations believed was the pigment of heaven itself. They were not wrong, but they did not know that heaven, when ground to dust, could also kill. Azurite, chemically, Cu3, open parenthesis, CO3, close parenthesis, 2, open parenthesis, OH2, close parenthesis, is a basic copper carbonate born in the oxidized zones of copper ore deposits. Where oxygen, moisture, and metal collide, it forms clusters of deep blue monoclinic crystals, sometimes botryoidal, sometimes needle-like, always magnetic to the eye, to miners in antiquity. Finding azurite meant copper was nearby, wealth beneath the color. To alchemists, it was a bridge between earth and spirit. To modern science, it is a reminder that beauty and toxicity often share the same breath. In ancient Egypt, priests crushed azurite into powder to paint the eyelids of pharaohs and gods. Its color symbolized protection, the third eye of Ra, the gaze of wisdom. But the pigment's copper content seeped into the skin, causing blindness and slow poisoning. The same fate befell medieval painters who mixed blue verditer, azurite's powdered form, into frescoes. They described dizziness, metallic taste, and paralysis. Beauty demanded tribute in breath and blood. When freshly mined, azurite's hue is unlike any other, a velvety ultramarine, so dark it seems to absorb light. Under sunlight, it shifts. Flashes of cobalt and indigo ripple across the surface like ocean waves. But with time, air transforms it. Slowly, invisibly, azurite dehydrates into malachite, turning green as the copper oxidizes further. What was sky becomes earth again, a perfect cycle of transformation and decay. In the Bisbee mines of Arizona and the Tuisit district of Morocco, miners still find spectacular rosettes of azurite crystals growing alongside malachite, the two locked in eternal dialogue, blue dreaming of green, green remembering blue. Each specimen is a geological heartbeat, frozen evidence of air meeting metal underground. For collectors, pristine azurite is treasure. Perfect crystals with mirror luster from Morocco or Namibia can sell for $1,000 to $6,000, depending on depth of color and form. Gem cutters, however, approach it with fear. The mineral is soft, Mohs 3.5 to 4, brittle and laced with copper. When polished dry, its dust is toxic, capable of causing metal fume fever and neurological damage. Modern lapidarists grind it only underwater, under ventilated hoods, masks sealed tight, a ritual as much as a craft. Under ultraviolet light, azurite glows faintly violet, a ghost of its ancient brilliance. Under a microscope, its crystalline walls appear as perfect prisms filled with darkness, tiny mirrors that swallow light. It's easy to see why mystics once believed the stone could open visions. Staring into it feels like looking into the depth of time itself. And yet, its lesson is caution. Azurite teaches that even the color of heaven is born from corrosion, from the slow death of metal inside the earth. Every glimmer is the echo of oxidation. So when you hold it to the light, remember this. What you see is not the sky trapped in stone, but the earth dreaming of forgiveness. Stone number 10. Malachite, the green guardian and the serpent's breath. Deep beneath the Katanga copper belt of Congo, the walls shimmer like scales of a sleeping dragon, layers of swirling green. Dark as forest shadows, light as new leaves, spiral together in hypnotic rhythm. This is malachite, the guardian stone of miners, jewelers, and kings. And one of the Earth's most deceptive gifts, malachite, chemically Cu2CO3OH2, forms in the oxidized zones of copper ore deposits, the same veins that give birth to azurite, its deep blue sibling. Where air, moisture, and time touch copper, it begins to transform. Blue turns to green. Life grows from decay. The result is a stone so vivid it seems to breathe. Ancient civilizations called it the flesh of the earth. They were right. In ancient Egypt, malachite was more than a gem. It was a passage powdered and worn around the eyes. It symbolized resurrection and protection in the afterlife. Pharaohs were buried with it. Temple walls were painted in its hue, but the very pigment that symbolized eternity carried death within. The fine green powder of malachite contains toxic copper compounds. Inhaled or ingested, it attacks the liver, kidneys, and nervous system. The artisans who painted tombs in malachite's glow often coughed blood long before their work was finished. In Tsarist Russia, malachite became the stone of empire. Palaces gleamed with massive pillars of green, none more famous than the malachite room in the Winter Palace, St. Petersburg. Each column, carved from tons of ore mined in the Ural Mountains, shimmered like petrified waves. Yet the miners who unearthed it labored in poisoned dust, their hands and lungs stained with the same color that lined imperial walls. To the eye, malachite is mesmerizing, banded concentric rings of forest, mint, and jade green, forming patterns so organic they resemble wood grain or fingerprints. No two pieces are ever alike. Polished, it becomes glass smooth, revealing layers like growth rings of time under sunlight. It seems alive, the green of birth and rot combined. But it is fragile, reactive, and demanding. Heat it, and it releases toxic copper oxide fumes. Grind it dry, and the dust becomes venomous. Lapidarists who shape it must work submerged in water, wearing masks, gloves, and respect. Museums keep it sealed in low-humidity glass. Restorers never polish it twice. Malachite's lesson is simple: beauty without care turns deadly. Economically, it remains one of the world's most beloved ornamental stones. Perfect slabs from Congo, Namibia, and Russia can fetch $1,000 to $10,000, depending on pattern and polish. Smaller cabochons are popular in jewelry, usually sealed with resin to protect skin from direct contact. Still, no gem cutter forgets the truth. This stone guards its life fiercely. To geologists, malachite is a chronicle of oxidation, the Earth's diary written in copper and air. To mystics, it's a stone of transformation, but to those who have mined it, it is both blessing and curse, a mineral that feeds and poisons, protects and punishes under magnification. Its concentric rings look like topographic maps of forgotten lands, rivers, forests, storms, all spiraling toward a green heart. And if you stare long enough, you'll feel it. The heartbeat of copper, pulsing under your skin, reminding you that even guardians have fangs. Stone number 9. Bolite, the ocean trapped in poison. In the burning deserts of Baja California, Mexico, there is a ghost town named Boleo, a place where the air once shimmered with blue dust. The miners there were chasing copper, but what they found instead were tiny cubic gems the color of deep sea, jewels that looked alive under sunlight. They called them bolite, and for a brief moment, the desert seemed to hold its own ocean. Bolite is a rare lead-copper-silver halide with the composition KPBB2Cu6OH, 16Sil-4-3H2O, a chemical labyrinth of metals, chlorine, and water. To the untrained eye, its crystals are perfect cubes of cobalt blue, transparent at the edges, glowing like sapphire ice. But beneath that beauty lies toxicity. Each cube is a quiet cocktail of lead and copper chlorides, both heavy metals capable of causing slow, irreversible poisoning when handled or inhaled as dust. The mineral was first discovered in the late 19th century at El Boleo mine in Santa Rosalia, hence its name. Miners described veins of blue glass running through the oxidized lead ore. They carved it from the rock with bare hands, unaware that the salt-rich air was carrying microparticles into their lungs. Years later, sickness swept through the settlement, trembling, fatigue, blurred vision, the invisible signature of lead and copper poisoning. Yet bolite's beauty refused to be forgotten. Its structure, a perfect cube, sometimes twinned into delicate star-like clusters, fascinated mineralogists under polarized light. Its inner lattice refracts in brilliant flashes of azure and indigo, as if sunlight itself had crystallized under water. When placed beside water, the illusion is uncanny. Bolite looks like solidified ocean. But it is fragile. Both physically and chemically, expose it to humidity, and it begins to decompose, turning dull and flaking away. Wash it, and the water slowly steals its blue. In museums, it is kept under glass, dry and sealed, its radiance preserved by silence. Even gentle touch can leave fingerprints of corrosion. The paradox is exquisite. The stone that looks like water cannot survive water. Collectors prize it as one of the most enchanting yet untouchable minerals on Earth. A pristine cube no larger than a fingertip can fetch $500 to $3,000, depending on clarity and origin. The best specimens still come from El Boleo, though fine examples have since been found in Chile, England, and Australia. Each one is a relic of chemistry at its most fragile, where the balance between light and poison is exact. Under ultraviolet light, bolite shows faint blue fluorescence, like moonlight through glass. Under magnification, its edges blur, not from imperfection, but from decay, the slow exhalation of chlorine atoms escaping the crystal. To watch it over years is to witness beauty dissolve in real time, and that is the tragedy and genius of bolite. It is the sea fossilized into geometry, but it carries the same salt that corrodes ships and bones alike. Hold it too long, and it will fade. Touch it, and it will crumble. But from a distance, behind the safety of glass, it remains eternal. The ocean, reborn as crystal, forever remembering what it cost to become blue. Stone number 8, Baildonite, the green flame of arsenic. In the sun-scorched hills of Cornwall, England, there is a valley where the rocks sweat green. The old miners once said the earth there bled color, veins so vivid they glowed like jade when wet. Those veins belonged to baildonite, a rare mineral that seduces the eye with emerald fire and betrays the flesh with poison. Baildonite is a lead-copper arsenate hydroxide with the composition PbCu, 3 open parenthesis, ASO 4 close parenthesis, 2 open parenthesis, OH close parenthesis 2, a mineral born from decay, formed when galena and chalcopyrite slowly oxidize in air and moisture. Its beauty rises from corrosion, not creation. It grows as velvety crusts and botryoidal clusters of intense green, sometimes speckled with gold or turquoise hues under sunlight. Each curve gleams like a drop of molten metal. Under ultraviolet, it shimmers faintly, the ghost of its arsenic heart. It was first identified in the late 18th century at Wheel Gorland Mine, Cornwall, and later in Sumeb, Namibia, and Laurium, Greece, all ancient graveyards of lead and copper ore. The miners who first touched it found it soft, silky, and strangely warm. Some believed it brought luck. Others noticed the dizziness that followed hours in those tunnels. The truth came later. Baildonite was exhaling arsenic oxide dust, invisible and fatal. Even in solid form, its danger is subtle. Grind it to powder, and it releases arsenic vapors when heated. Handle it barehanded too long, and copper ions can absorb through skin. In ancient times, fragments of baildonite were mistaken for malachite or chrysocolla, both used as pigments and medicine. A single error in preparation could turn healing powder into poison, yet it remains mesmerizing. To look at baildonite is to see nature's paradox, a mineral that seems alive, breathing color. Its texture resembles green velvet, petrified, with delicate concentric ripples like tree rings. In rare cases, baledonite forms transparent microcrystals that flash with chartreuse and olive light, as if sunlight were trapped inside moss. Modern collectors prize it as both treasure and warning. The best specimens, particularly those from the Tsumeb mine, display layered associations with mimetite, azurite, and malachite, three colors woven together in a mineral symphony of green, blue, and gold. These masterpieces can fetch $1,000 to $4,000, though they're never touched bare. In museums, baledonite sits under sealed glass, marked with small radiation symbols not for fear of radioactivity, but for the invisible breath of arsenic that escapes when it's disturbed. Under magnification, baledonite's surface looks like living skin, pores, folds, microcrystals glinting like dew. It is geology's illusion of biology. Every curve is the record of chemical tension, lead meeting oxygen, copper meeting time, the earth oxidizing itself into art. To the historian, baledonite is a reminder that the line between alchemy and geology was once perilously thin. Miners called it green fortune. Healers ground it into powder of renewal. Yet every attempt to harness its power ended in the same quiet fate, the air growing heavy, the lungs tightening, the skin paling to match the stone. So when you see its emerald glow through the glass of a museum case, remember, it's not just color you're looking at, it's chemistry in motion. Baledonite does not shine to be admired. It shines to remind the living what the earth keeps buried. Stone number 7. Anglesite, the crystal of lead and false purity. Off the storm-beaten coast of Anglesey, Wales, miners once dug into the cliffs to find a mineral that glowed like frozen lightning. Its crystals were so clear, so luminous, that they believed it to be a fragment of the divine, a light trapped beneath the earth. They called it Anglesite, after the island where it was born. But the light they worshipped came from one of the heaviest, most poisonous metals known to man, lead. Anglesite, chemically PbSO4, lead sulfate, forms when galena, lead sulfide, one of the oldest and most widespread ores in history, weathers and oxidizes. The transformation is slow and quiet, a kind of geological alchemy where black metallic ore turns into translucent crystal. It is the moment when darkness becomes clarity and poison becomes beauty. Its crystals grow in perfect orthorhombic prisms, often colorless, sometimes tinted pale yellow, gray, or sky blue. Depending on impurities under the torch, they gleam like glass. Under daylight, they refract light with a solemn purity. To miners of the 18th century, Anglesite was a promise, a sign that valuable lead lay nearby. To collectors today, it's one of the most hauntingly beautiful reminders that transparency can conceal danger. Hold it in your hand, and it feels heavier than it should. Lead gives it an unnatural density, gravity made visible. Ancient Romans once used lead-glazed ceramics and pipes, believing them symbols of luxury. Now we know they were slowly poisoned by their own refinement. Anglesite embodies that same irony. It is beauty that cannot be touched. In the mines of Tsumeb, Namibia, Tuisi, Morocco, and Broken Hill, Australia, Anglesite forms as thin layers coating old galena veins, ghostly afterimages of the ore that birthed them. When the lights of the mine flicker, the crystals catch the glow like shards of mirror, creating the illusion of stars underground. But inhaling the dust from those same chambers, or touching wet specimens with bare skin, can introduce lead sulfate into the body, where it accumulates in bone and blood. It is the kind of poison that doesn't kill quickly, but waits. Still, collectors chase it. Fine, transparent crystals, perfectly terminated, gem-clear, and mounted on dark galena, can sell for $800 to $3,500, depending on size and clarity. In museum cases, the finest specimens look like raindrops frozen mid-air. Curators handle them with tweezers, never fingers. Even a trace of sweat can tarnish the surface, altering the delicate play of light across the crystal's face. Under ultraviolet light, Anglesite glows faintly white, almost angelic, fitting for a mineral that shares a name with angels. But look closer, and that radiance feels cold, clinical, sterile. Its purity is the kind that warns, not comforts. To the archaeologist, anglesite is more than a mineral. It's a parable. It tells the same story written in Rome's plumbing, in Victorian paint, in the poisoned soil of industrial towns. That human fascination with brightness has always come at a cost. When you gaze into an anglesite crystal, it gazes back, clear, calm, indifferent, like history itself. Because the earth never lies. It only reflects what we choose not to see. Stone number 6. Chalcanthite, the crystal that drinks life. In the abandoned copper mines of Arizona and deep beneath the deserts of Chile, there is a stone so blue, so electric, that it seems almost unreal. A phantom glow in the darkness, miners once followed its neon shimmer through crumbling tunnels, believing it marked the presence of rich ore. What they found instead was a crystal that formed not from stability, but from decay. This is chalcanthite, the mineral that drinks life from everything it touches. Chemically, chalcanthite is copper sulfate pentahydrate, QSO4-5H2O, a compound so reactive that it dissolves in water, poisons soil, and kills every living thing in its path. It forms only in arid, oxygen-rich environments, often in places where mines have long been abandoned. When groundwater evaporates through cracks in old copper veins, it leaves behind glowing blue crystals. Surreal, transparent, and deadly to the eye, chalcanthite is breathtaking. Its crystals grow in perfect prismatic blades, shimmering between sapphire blue and icy turquoise. Place it under a lamp, and it glows as though lit from within. In the 19th century, miners called it blue fire, believing it was the earth's way of marking sacred ground, but the truth was harsher. Touch the stone with bare hands, and copper ions seep into the skin. Drop it into a pond, and the water turns lethal within hours. Entire sections of wildlife around old mines died without warning, poisoned by a beauty too bright to be safe. Because chalcanthite dissolves so easily, its crystals in nature are temporary, fragile sculptures shaped by evaporation. This ephemerality made it all the more coveted. Collectors would break glowing clusters from cave walls, only to watch them collapse in humid air. Even today, perfect natural specimens from Chile or Arizona can fetch $800 to $3,000, but they must be kept sealed, dry, untouched by moisture. A single fingerprint can start a chemical reaction. Its danger is subtle but absolute. Copper sulfate is fatal to plants, insects, fish, and mammals. It was once used, sparingly, as a pesticide. In mineral form, chalcanthite behaves the same way. Museums store it in airtight glass, not simply to preserve the crystal, but to protect the air around it. Lapidarists refuse to cut it. Jewelers will not touch it. And geologists handling it wear gloves, masks, and the same caution reserved for laboratory chemicals. Under the microscope, chalcanthite looks almost like frozen lightning. Long, intersecting blades, each one transparent and sharp. But hidden between those shimmering layers is its true power: solubility. It wants to dissolve. It wants to spread. It wants to drink the life of whatever holds it. To collectors, chalcanthite represents the ultimate paradox: beauty that cannot exist without decay, color that lives only by consuming life, a crystal that kills by dissolving itself. Stand before a perfect chalcanthite specimen, its blue fire glowing through glass, and you'll understand. Some exist only as warnings the earth leaves behind, brilliant reminders that life and death are sometimes separated by nothing more than color. Because chalcanthite doesn't just shine, it spreads. Stone number 5. Stibnite, the silver blades of death and empire. In the misty mountains of Sichuan, China, miners still whisper of a metal that gleams like moonlight and cuts like betrayal. Hidden in dark veins beneath volcanic stone, it grows not as chunks or dust, but as blades. Perfect metallic spears, long, sharp, and cold. This is stibnite, the mineral once mistaken for silver, once used to heal, to kill, and to crown. Stibnite, Antimony sulfide, Sb2S3, forms in hydrothermal veins where hot sulfuric fluids meet antimony-rich rock. Over time, these fluids cool and crystallize into towering metallic prisms, some over 30 centimeters long, slender and mirrored like forged steel under light. They reflect with a gunmetal luster so pure that ancient miners believed they had found a divine metal. They were half right, for stibnite became both a sacred tool and a silent weapon in human history. In the ancient world, powdered stibnite was used as kohl, the same black pigment that lined the eyes of Egyptian queens and Mesopotamian priests. They believed it warded off evil spirits. In truth, it slowly infused their bodies with antimony, a heavy metal toxin that numbs the nervous system and burns the skin. The line between devotion and destruction was as thin as the mineral's edge. By the Middle Ages, alchemists had discovered stibnite's strange power. When heated, it purified gold, absorbing impurities like a dark sponge, but in the process, it released clouds of antimony trioxide, a deadly fume. In the 16th century, Basil Valentine, the German alchemist monk, called it the wolf that devours the sun, because it consumed gold only to reveal it brighter, a perfect metaphor for beauty through suffering the greatest minds. In China's Wuning County, Japan's Ichinokawa mine, and Romania's Baia Spree, yielded forests of glittering crystals so spectacular that some still stand intact in museums today. The Ichinokawa specimen, now in Tokyo, measures over 2 meters across, a metallic thicket that looks more alive than dead. Yet every inch of that beauty carries danger. Touch it with bare hands, and trace amounts of antimony leach through the skin. Heat it, and it exhales a colorless vapor that burns the lungs. The miners who once extracted it bare-faced rarely lived to old age. Despite its toxicity, stibnite shaped the modern world. Refined antimony became the heart of flame retardants, batteries, and bullets, the paradox of a poison-turned protector. Its silvery shimmer found its way into cosmetics, its compounds into medicine, even into glass-making. Humanity learned to use the wolf, but never to tame it. To the eye, stibnite remains one of nature's most mesmerizing structures, needle-like columns radiating in geometric perfection, like organ pipes cast from moonlight under the lens. Its surface reveals subtle rainbows, oxidation layers of blue, violet, and amber. As if the metal remembers its own melting, collectors treat it like royalty. Perfect crystal sprays from China and Japan fetch $1,000 to $6,000, depending on size and luster. But they are fragile. A single vibration can snap them into dust museums, cradle them in foam-lined boxes, away from humidity, for even air can tarnish their glow. To the archaeologist, stibnite is a mirror, not of light, but of human ambition. We have always polished poison into elegance, turned danger into ornament, and called it progress. Under dim light, the crystal forest glints, sharp, silent, eternal. A monument to every empire that mistook reflection for purity. Because stibnite doesn't shine for us. It shines to remind us what we never learn. Stone number 4, cinnabar. The crimson curse of kings beneath the ancient hills of Almaden, Spain. The rock bleeds red when struck. For over 2,000 years, men followed that blood, into the earth, into fortune, and into madness. What they were mining was not gold, not iron, but something far older and far more seductive. Cinnabar, the crimson ore that gave birth to the color of royalty and the poison of death. Cinnabar, mercury sulfide, HGS, forms in volcanic and hydrothermal veins, crystallizing near the Earth's surface where heat still whispers. It glows with a metallic scarlet sheen so deep it looks alive. To ancient eyes, it was magic, a stone that could burn without flame, a pigment so rich it made blood look pale. From it, they extracted mercury, the liquid silver that would later reshape empires and science alike. But the price was always the same, slow, irreversible poisoning. The Romans mined it first, deep beneath Almaden, sending slaves into narrow tunnels where air shimmered with invisible vapor. The red dust clung to skin and hair like rust. Within months, the miners trembled, their teeth blackened, their minds slipping away. Yet the pigment they produced, vermilion, adorned the walls of emperors' villas, the statues of gods, and the lips of noblewomen power wore the color of its own decay. In China's Shaanxi and Guizhou provinces, cinnabar was revered as sacred. Taoist alchemists ground it into elixirs seeking immortality, believing the red essence contained the life force of the earth. The irony was cruel. Those who drank it glowed with color, then withered from within. Mercury's slow poison crept through veins and mind alike, blurring dreams into delirium. Even so, emperors continued to swallow it. Immortality was worth a shorter life, if it shone bright enough. Geologically, cinnabar crystallizes in rhombohedral or granular forms, with shades ranging from blood red to silver-gray underlight. Its luster flickers between glassy and metallic, a duality as deceptive as the element it conceals. When heated or exposed to sunlight, it releases mercury vapor, invisible and deadly. One breath is enough to scar lungs, years of exposure to unmake a mind. Yet the stone's beauty is undeniable. A single polished fragment can glow like a coal trapped in glass. Artists across centuries risked their lives to paint with it, from Roman frescoes to Renaissance altarpieces, from Persian manuscripts to Chinese lacquerware. The pigment endured for millennia, outliving its makers. Their bones faded, but the red on their art remains untarnished, an eternal record of human vanity. Today, the mining of cinnabar is forbidden in most nations. Its legacy continues only in sealed museum drawers, under labels marked toxic. Modern mineralogists handle it with respirators and gloves, storing it in glass cases where no air can stir its fumes. But even from behind that barrier, it captivates. In those red facets, we see the story of ourselves, our need to hold beauty, even when it burns. Collectors pay high prices for perfect crystals from Spain, China, and Peru, $2,000 to $10,000, depending on purity and luster. But the true worth of cinnabar is not measured in money, it's measured in history. The pigment that crowned emperors, painted heavens, and poisoned saints under magnification. It looks like molten fire cooled to stillness, every facet a reminder that color itself can kill. Cinnabar is the oldest lie the earth ever told humanity, that beauty can be possessed without cost, because every empire that sought immortality in its glow found only the reflection of its own extinction. Stone number 3. Realgar, the fire that devours its makers. In the dim light of ancient Chinese mines in Hunan and the Persian mountains, there is a stone that burns without flame. It glows the color of molten sunset, deep orange, almost red, as if the earth itself were bleeding light. This is realgar, one of the most treacherous minerals ever unearthed, beautiful, luminescent, and fatally alive. Realgar, arsenic sulfide, As4S4, forms in volcanic veins and hot spring deposits, often alongside its yellow sibling, orpiment. Where heat, sulfur, and decay converge, realgar grows in fragile crystals that look almost edible, translucent as candied fire. The Greeks called it sandarake, red lead. Believing it held the essence of the sun, alchemists later named it ruby of the philosophers, a key ingredient in their impossible pursuit of gold. But its radiance hides an ancient curse. Arsenic, the element that kills softly. From the Han Dynasty to the Renaissance, realgar was both remedy and poison. Physicians prescribed it in small doses to purge evil vapors. Painters crushed it into pigment, mixing its ember hue into murals and manuscripts, and alchemists, the eternal dreamers, used it to simulate transmutation, for when realgar burned, it released a white smoke that shimmered like silver, but that smoke was arsenic trioxide, invisible, sweet-smelling, and fatal. The miners who worked the veins of realgar knew death by other names: dizziness, trembling, bleeding gums, blindness. Their bodies absorbed the dust slowly, their skin growing pale, their minds confused, a living ghosting known as arsenic bloom. Yet the world above continued to covet the color they dyed to deliver. Chinese emperors lacquered their palaces with it, European manuscripts glowed with it, Persian robes shimmered under its hue. Realgar became the color of sacred fire and human ambition. Under daylight, it glows like amber mixed with blood. Under candlelight, it seems to move, flickering as though still alive. But expose it to too much light, and it betrays its maker. Realgar degrades into a yellow powder called para-realgar, losing its shape and strength, releasing arsenic dust into the air. Even in death, it poisons. To this day, museums keep it sealed in black cabinets, touched only by gloved hands. In modern mineral collections, intact realgar crystals are treasures of fragility, often stored away from UV light and moisture. Perfect specimens from Shaiman Mine, China, or Nakhichevan, Armenia, can fetch $1,000 to $5,000, their value based not on rarity, but survival. Each piece is a race against decay. Time itself gnaws at the stone, turning orange flame into yellow ash. Under a microscope, realgar looks like crystallized fire. Smooth walls of refractive red intersected by golden fractures. Every facet reflects both beauty and death. The longer it's exposed, the duller it becomes, a self-consuming ember in mineral form. Scientists call it photosensitive decomposition. Poets might call it remorse. To the archaeologist, realgar is not just a mineral. It is a confession of humanity's endless chase for radiance and its blindness to the cost. It is the flame that does not warm, the color that erases its painter, the alchemist's deceit turned to dust. In every culture that touched it, realgar left the same mark. Beauty that fades, sickness that stays, brilliance that kills slowly but never forgets. And as the last surviving crystals sit locked behind glass, they whisper the same truth in a hue no artist can replicate, that even light, when stolen from the earth, can turn against the thief. Stone number 2. Orpiment, the golden lie of the earth. Deep in the sunlit caves of Turkey's Cappadocia and the mountain valleys of China's Hunan province, there glows a mineral that seems to carry sunlight itself. It shimmers like powdered gold, soft and radiant, folding light into every edge. This is orpiment, once called aura pigmentum, the color of gold, the stone that deceived alchemists, painters, and kings alike. Orpiment, arsenic trisulfide, As2S3, forms in hydrothermal veins and volcanic fumaroles, often side by side with its fiery twin, realgar. Together they were once considered the physical embodiment of the sun and its shadow. To the naked eye, orpiment appears as lemon yellow to orange gold sheets of crystal, silky, soft and luminous under light. Its brilliance is seductive, a warmth so pure it feels divine. Yet every gram contains enough arsenic to silence that divinity forever. In the ancient world, orpiment was treasure. Egyptian scribes crushed it into pigment for sacred scrolls. Chinese alchemists used it to paint talismans of immortality. Persian artisans blended it into gold leaf to give heavenly shimmer to manuscripts and mosaics. In Rome, emperors ordered it imported by the ton, paying more than for true gold. And yet, every artist who ground it, every monk who illuminated scripture with it, was slowly undone by the dust. Arsenic's kiss is soft, silent, irreversible. Medieval apothecaries believed orpiment could cure disease, cleanse the blood, or expel spirits. Instead, it expelled the living. The fumes from heating it released arsenic trioxide, a gas that attacks the lungs and nerves. In the alchemical furnaces of Europe, realgar and orpiment were combined in the quest for aurum philosophicum, the legendary gold of wisdom. What the alchemists created instead was poison vapor, sweet-smelling and invisible. They died surrounded by the very glow they worshipped. Even so, orpiment's beauty endured. During the Renaissance, it was ground into the pigment king's yellow, a paint so brilliant that artists risked their health to use it. Masters like Titian and Vermeer painted with it, unaware that their studio's golden haze carried slow death. Later, when synthetic cadmium and chrome yellows were invented, orpiment's reign ended, but its legend remained, a warning written in gold. Geologically, orpiment is fragile. Its crystals are soft, flaking, and photosensitive. They crumble under pressure and fade under sunlight, turning dull and powdery as they decompose. The same light that gives it beauty takes it away. In museums, orpiment lives in darkness, sealed behind glass where even a breath of air could trigger its decay. Under the microscope, it is mesmerizing, feather-like blades of translucent yellow, reflecting light like liquid fire. Some pieces seem to glow from within, as though remembering the volcanoes that birthed them, but that radiance is treacherous. The slightest moisture can release toxic vapors. Even gloved hands leave microscopic oils that hasten its fall. Collectors treat it with near-religious caution. Perfect specimens from Xiamen, China, or Nevada's Getchell mine can command $2,000 to $6,000, yet few ever touch them twice. Handling orpiment is an act of reverence or risk. To the archaeologist, orpiment is not simply a mineral, but a mirror of human desire. It is the golden promise that never delivers, the beauty that demands silence. It reflects the same delusion that built temples and toppled empires, the belief that something radiant must also be pure. But in truth, orpiment is purity's illusion. It glows not because it holds the sun, but because it hides decay. Look closely, and you'll see the truth behind the light. The earth has always known how to make gold. It just never meant it for our hands. Stone number 1. Thorite, the silent dawn of the atomic age. High in the misty fjords of Norway, in a valley called Levoya, miners once uncovered a black, glassy stone that shimmered faintly red under sunlight. It looked ordinary, dull, fractured, heavy, but it pulsed with an unseen fire. They called it thorite, after Thor, the Norse god of thunder. It was an appropriate name, for this stone would one day thunder across history, quietly igniting the atomic age. Thorite, Thesio4, is a thorium silicate, a mineral so dense it seems to pull gravity toward it. Found in granitic pegmatites and metamorphic rocks, it often forms alongside zircon, monazite, and uraninite, a family of elements that would become the foundation of nuclear energy and weapons. Its crystals, typically black, brown, or amber-orange, are opaque at first glance, but under magnification, they glow with an ember-like translucence, as if lit from within. When the mineral was discovered in 1828, no one understood its significance. It was just another heavy, lustrous stone, but within it lay thorium, a radioactive element that emits heat for millennia, silent, invisible, unstoppable. In the decades that followed, scientists isolated thorium from thorite and realized its potential. It could generate energy through nuclear decay without the violent instability of uranium. It was the gentler fire, the one humanity might someday learn to control. Yet, for the miners and geologists who handled it, ignorance was lethal. Thorite's radiation is subtle but relentless. When crushed, its fine dust releases alpha and gamma particles that damage lungs and bone marrow. Early collectors stored it on desks and shelves, unaware that the faint warmth they felt through glass was radiation. Some reported strange sunburns, fatigue, and headaches, the earth whispering its warning through decay. The stone itself is paradoxical, both stable and dying. Over centuries, thorite undergoes metamictization, a process where its crystal structure collapses under its own radiation, turning glassy and amorphous. In essence, it slowly destroys itself, a mineral committing atomic suicide. To hold an ancient piece of thorite is to cradle time disintegrating in your palm. Despite its danger, thorite became a cornerstone of scientific progress. Its thorium fueled early gas mantles, the glowing lamps that lit Europe in the 19th century, and later, experiments in nuclear power engineers dreamed of thorium reactors, clean, efficient, nearly eternal. But those dreams faded in the shadow of uranium and plutonium, whose destructive potential proved more seductive to nations. Thorite, like its mythic namesake, was left to sleep again in stone. Visually, it remains understated, matte, rough, sometimes dull as coal, until struck by light. Then, deep veins of reddish-orange fluorescence emerge, a reminder that even death glows under the right gaze. Under ultraviolet light, it emits a faint, ghostly shimmer, as though the mineral itself remembers the stars it came from. Collectors treat it with both awe and fear. A well-preserved specimen, especially from Norway, Madagascar, or Ontario, can fetch $3,000 to $10,000, but few dare keep it unshielded. Museums store it behind lead glass, sealed in nitrogen atmospheres to prevent dust from escaping. It is displayed not for beauty, but for reverence, a relic of energy older than civilization. To the archaeologist, thorite is not merely a stone. It is the hinge between eras, between the age of myth and the age of atoms. It bridges the hammer of Thor and the mushroom cloud of humanity. In its silence, it hums, the low, eternal vibration of decay that built stars, planets, and our own mortality. And if you listen closely enough, you'll hear it whisper the same truth all radiant minerals share. Power is never born innocent. It is only borrowed. From time, we began this journey with 30 stones, each more beautiful, more dangerous, and more human than the last. From cinnabar's crimson curse to thorite's silent radiation, from the pigments that built empires to the crystals that destroyed them, every one of these minerals carries the same message, that the earth never gives beauty freely. The truth is, these aren't just stones, they are warnings carved in color, reminders that brilliance often grows where life cannot survive. We mine them, polish them, worship them. But in the end, it is always we who are changed, not the stone. So before you buy, before you collect, before you invest, remember this. Not everything rare is safe, and not everything that shines is meant to be owned. If you've watched until now, thank you for walking beside me through this hidden world beneath the glitter. I'm Sarah, your host from World of Gem, and if you want more journeys like this, don't forget to like, subscribe, and ring the bell to keep exploring with us, because the deeper we dig, the more we realize. The most dangerous gems are never the ones in the ground, but the ones that blind us with their beauty. Until next time, keep your eyes open and your hands clean. Welcome back anytime to World of Gem.